Hello, Tool Kids! Today on Tools for Teens, we're going to fill your heads full of information about electricity and circuits. So here's a circuit. A circuit is sort of like when you watch a baseball game and you see the runner running around the bases. Well, the bases are a little different here. Here's some electricity coming out of a battery, and the electrons are going around this circuit, and what do they come across? Here they're coming across a light, and this could be a battery or a heater or a buzzer or something else. Anyhow, the electrons are going through this very fine wire inside of here, and there's a vacuum inside, and when there's a vacuum inside, that allows this kind of wire that's in there, a special wire, to actually glow very bright and make light. So then the electricity continues around, and here's a fuse. Well, if too much electricity is going through the circuit for some reason, then that fuse, which is also very fine wire but not inside of a vacuum, that wire is going to zzz, and it's going to melt. Okay. Here's what happens when you put a whole bunch of volts through a very tiny wire. Uh-oh. So let's go a little further. Well, here, there's a switch. Well, if that switch is open, then this electricity can't go around in a circle. But when that switch goes closed, then the electricity can continue around and complete the circuit back to the power source, which in this case is a battery. Well, there's two kinds of electricity that most people talk about, and one part is called DC, and that's when the electricity goes one way around, and the other is called AC, which is when the electricity goes in both directions around the circuit. So those are the different parts that compose a circuit. Well, here's some examples of wire. This wire right here is something you might use to hook up your air conditioner, or something where you really need to bring a lot of energy from one place to another. And here's some wires. There's 3 of them in this kind of tube thing. And that's typical house wire, like you'd find in the walls of your house. Here's wire that you'd use for hooking things up that are lower voltage, like speaker wires in your stereo system, or something in a car. Here's wire that's thinner than that, that's really for, smaller voltage, lower amperage situations. And this is wire that you might find inside of a coil that's used to make these things like transformers, those things that are in the wall that you plug in the wall socket, and then it goes off to your computer or to your phone charger or something. And this one, which is about the size of a hair, okay, is something that you might find inside of a light bulb or inside of some fuses. Okay, you can compare that to the size of a quarter here. Anyhow, they all carry electricity, and the way they do that is they're all metal, and electrons get pushed by voltage into the next closest molecule of metal. And it goes like that, like a bucket brigade, from one end to the other end. And I'll show you more about how that happens. Think of voltage like water pressure. The push that pushes the water out of the pipes and into the bucket. Think of amperage as how fast the water comes out of the faucet and in to fill the bucket, or how fast the bucket would get filled. And think of resistance as how big the faucet is. Now, right in here, this knob makes the faucet very tiny, the passageway through here very tiny, and that represents the resistance. Now, if we have low resistance, then the water comes through real quick and fills up the bucket. When we have high resistance, which means there's a little passage in here in the faucet, well, that is a high resistance, and it takes longer to fill up the faucet, and so that's like having not too many amps going through here. That's basically all there is to it. There's different ways of getting electricity. You could get it from the wall socket, okay, and that's actually AC current, or you could plug something into the wall socket like this, which is called a wall wart or a transformer, and that's what might charge up your cell phone, okay, or something else, your computer. And you'll notice that there's two prongs here, and then this wire has two wires in it, and then it comes out to here, and there's actually two metal parts here. There's the outside part here, and then there's another little metal part inside of here to bring electricity through two pathways to that point. Okay, you'll see that everywhere you see electricity, you'll see two pathways. Okay, so here's a battery. This is a big motorcycle battery, and you'll see that there's a plus and there's a minus. This is for DC, okay, and there's two of them. This is a 12-volt battery. This is a 1.5 volt battery, okay, and it has two ends. There's this shiny end, and then there's an end that has a little end piece that sticks out here. Here's another 1.5 volt battery. This is a much smaller one that you might find in a little flashlight or something, but it also has that, and you'll see it's marked on here. There's a negative end. See that end, or that little line there for negative, and a positive end there. That helps you to orient it. Or maybe you've got one of these things. It's like a battery charger that you'd use to charge up a battery for a car, and it also has two. It has a plus, which is always red, or a minus, which is always black. Okay, and these are the ways that are real popular for getting electricity into a circuit. Okay, well, let's look at that circuit again. There's the battery, there's the load, which is a light in this case, and then there's a fuse sometimes, and then there's a switch, and then back to the battery again. So let's look. Here it is in real life. There's a battery, and this is 3 1.5 volt batteries, so there's 4.5 volts coming through here, and you see this little red wire and a black wire. Those are the two wires coming out of the power source, and this is going into a switch. See this thing right here? If you push this down, it makes contact through the circuit. If you hold it up, then it doesn't make contact. Well, let's see where it goes. If you put it down, then it would go through this wire into this wire, and that wire is connected up to a light bulb. Okay, there's a little light bulb, and if you look really close inside of a light bulb, you're going to see that those two fine wires are in there. Let's take a look at a little bit bigger light bulb here. You see those fine wires inside of there? Well, if you put electricity through there, and they're made out of something like tungsten, which is a special kind of material that conducts electricity. They'll glow very brightly. So let's go back here. There's our little light bulb, and then there's another wire coming out of the other side. Okay, and this wire is coming down to here, and that's going right back to the battery. So remember, now we're going to go around in a circle again. Here we go, through this, through the switch, and then into the light bulb, and then out of the light bulb, and then back to the battery. So here we go. I'm going to put down the switch, see what happens. We get electricity through the whole circuit, and now we're going to pull it up, and it turns off. So the switch turns it on and off and lets that electricity, lets those electrons go down the pathway through the metal and all the way around the circuit and make a home run. Okay, well, let's try something else. Let's take these wires that are on here and let's put them on something else. Let's put them on a motor. All right, I'm going to take this off here and put it on there. Okay, now let's try it again. We're going to flip our switch and see what happens here. There we go. We made our circuit all the way around. We went from the battery through the switch, and then from the switch into this wire, and that wire went over to the motor, and then from the motor it went back to the battery. Pretty cool, huh? Well, okay, well, how do motors work? Well, motors work because you take some very, very fine wire and you wrap it around a spool or something like that, and then you run electricity through that very fine coil of wire. And here, look at how fine this wire is. It's as fine as a human hair here. And this is a solenoid. You might find something like this inside of a doorbell or all sorts of places. Anyhow, we're all hooked up to our battery through a wire, and we're making a circuit. Here's another wire, and I'm going to make the switch just with my hand right here, and we're going to watch to see what happens when we put electricity through that coil. Watch. Did you see that move? Well, what's going on there is that we're creating a magnetic field, and that's pulling that piece of iron into the spool where all that wire is coiled around. And if you do it right, then actually you can do all sorts of things. You can make motors like we have over here, or all sizes of motors, and you can make doorbells. Here's a doorbell here, and that has the same thing going on. There's a coil of wire, and then there's this little thing that moves back and forth, and it's going to hit the doorbell. Okay, when the electricity goes through there, it hits the doorbell and it makes that ding. Okay, and then here is this is a headlight. Okay, and that also, if we hook up a light to it, if we hook up electricity to it, it's going to make lights. Here, let's see here if we can do that. Oh, look at that. Oh, look at that. Let's turn it over. And now you can see how it was hooked up in the back. Oh, I think we lost our connection there. Yeah, we did. Now let's hook it up again. All right, here we go. Whoa! That was pretty bright, huh? All right, let's try something else. Let's make another circuit. And this time, we're going to use a horn. Okay? Here's a horn from an old car. See that horn? Great big auga type horn. Here. So we've still got our circuit. We're going to hook up one side of it to one side of the horn, and we're going to hook up this to our battery again, and then we're going to hook this up to the other side of the horn. You ready? 1, 2, 3. We get lots of sparks here. That looks pretty cool. That's fun. Okay. Well, what else can we try here? Well, how about this? How about we hook up our motor to a fan, or hook up our battery to a fan that would be on a radiator in a car. Okay, can we try that? Let's try that. Okay, now here we've got our battery hooked up through wires to this fan. And this is a really powerful fan, so we're going to give that a try. We're going to take and we're going to use this as a switch. We're just going to touch this, and I'm going to be the switch, and we're going to watch it. Now watch which way the fan turns. Went counterclockwise, right, when we did that? Now watch this. What I'm going to do is I'm going to switch these wires between here and here. I'm going to switch them around, okay, so that the electricity is going the other way around through the circuit. Look at that. Clockwise now. That's pretty cool. Okay, now do you remember how we talked about the size of the faucet being what they called resistance, or that's kind of like the size of the wire, or how much electricity you could let through something at a time? Well, this thing is called a resistor, and the more wire that is in this circuit, okay, that the electricity has to go through, the slower that the electricity can go through it, just like if you had a smaller tube for the water to go through. Now we hooked up the battery to the motor, through the resistor and back to the battery again. Okay, and so now, right now, there's a lot of resistance, and it's really not letting any electricity through the motor. But watch what happens as I change the resistance so there's less resistance in the circuit. Just watch what happens here. And I put a little flipper on there. Okay, so now we've got, maybe 3 volts going through there out of 12. So let's give it 8 volts or so. Let's give it 12 volts. Whoa! Let's go down again. More and more wire. More and more resistor wire to go through. It's like a longer and longer and smaller hole in that faucet. Until it can't make the motor run anymore. There's almost no voltage that's getting through that circuit now. All right, that's pretty cool. All right, did you ever wonder how radio works or how a speaker works? Well, basically some electricity goes through a circuit, and it goes into a wire that goes into a speaker, okay? And depending on how electricity is turning on and off, it can make a sound, Okay, different sounds. So let's just take, and we're going to add the circuit to it. Okay, let's see if we can make a circuit with this sound here. Okay, ready? Oh! Now right in there somewhere, if I were to put a microphone right there, right between there, I might be able to make music. See? Okay, now here's something fun. This is a little gadget, like a little game that I made many years ago for my little boy. And this illustrates what we've been learning about. Okay, there's some batteries, and there's a light, and there's a wire that goes from the battery into the light, and it goes out of the light, and it goes into a buzzer, and it goes out of the buzzer, and it goes to this piece of wire. Okay, and that piece of wire is suspended above there. Now the other side of the battery actually is hooked up to a wire, and that wire goes to this wand. Okay, so if this wand touches this wire, it completes a circuit, just like those other circuits we've looked at. But the trick here, the trick is to get all the way around and not hit the two together and complete a circuit. So I'm going to try and do it here and see if I can do it without touching them. But if I do touch them, uh-oh! Let's see if I can go a little further here. I have to turn the corner. Oh! So that's 2. That's 3, 4, 5. It's hard to... I'm going to give up. Anyhow, that is how that works. That's a fun little game, and it's just the same circuit that we've looked at before. Well, if you look around the house, you're going to find circuits and wires and electricity everywhere. And it's kind of a game to figure out how it's coming and going. But try the game. Oh, the key word for today is spark. I'll see you next time on Tools for Teens.